Hey, so in this video, we're going to talk about hypothesis tests for population proportions. And so make sure you've read 104 to 109 in your lab manual. Go over those pages, read through, try them the best you can. We're going to be doing the bottled water example and the political polling example. And there's actually a third example after that called school bullying. So if you feel like you need more practice, feel free and do that problem and then email it to me and I can go over it with you if you're still having trouble with these population proportion problems. This book does use a few different notations than we use in class, so whichever one you are more comfortable with is absolutely fine. So here we are on page 104. And it's the bottled water challenge. And so it walks through steps. And first thing we're going to do is talk about the hypothesis. So I want to state the null and alternative hypothesis. So just as a reminder, less than is the left-tailed, greater than is a right-tailed, and not equal to is a two-tailed test. And that's all for the alternative. And for the null, we're always using that equal to just to be consistent. And then that way we don't have to worry about different notations. Okay, so what we have in this problem for the bottled water is we have the null alternative and the null hypothesis and the alternative hypothesis. And since we're talking about proportion, it's both P. And again, it's really obvious that we're talking about proportion because that's all I've been saying and it's right here in the title. However, in the problem, the reason you can tell that it is a proportion problem is one, they're giving us these percentages, not this. This is alpha. This is alpha. So alpha is always going to be a percent as well. So I'll just write that right now. Alpha is 0.05. But when I read the question and I see that 70% prefer bottled water is what the friend is estimating, and then you sample and it tells you how many you sampled and then how many preferred it, that's definitely giving us an X in this problem. Remember, they all have N's, they all have sample sizes. But if all I can find is the X and I don't know anything about the mean or the standard deviation, then this is definitely a proportion problem. And so I have this guess right here, this estimate, that will be my P as a decimal. And then I have my X and my N, so I'm ready to jump in. We said that P is equal to 0.7. So that will be our null hypothesis at 70%. For the alternative, what are we claiming? They estimate that. You find this estimate to be low and you want to test the hypothesis. So if you find the estimate to be low, that means that you're guessing that it should be bigger than that. So that this means should be greater. So it doesn't always use the phrase greater than or less than or more or less in the problem. So that sometimes you have to read into it a little bit. You find this estimate to be low. Well, if it seems a little low, that means you're saying it should be bigger than that. So greater than 0.7 for our alternative hypothesis, and then greater than is right-tailed. You should be pretty comfortable saying right-tailed and left-tailed and two-tailed from the alternative, but as a reminder, it's listed right up here on the previous page in case you forgot. All right, so explain why we chose the alternative hypothesis that we did. Well, what did we say in my? We find the estimate to be low. So that was the phrase that got us to that alternative. That's the phrase we used to tell us that we wanted to do a greater than alternative hypothesis. And we already answered that, but it is a right-tailed test. Okay, so now looking at D, sometimes And this is what I meant at the beginning when I said, answer the best you can and just kind of use the symbols that you feel most comfortable with. This book has this other way of doing it, and that's fine, but you can also do what we were talking about in the lecture and say P and Q are both, wow, okay, let me just start over, that one was terrible. Delete. Okay, can't just delete things, I don't even know how a G got in there. P and Q are both 5 or more. Okay, how do I know this? Well, we were given P in the problem. I guess P and Q, that's actually the wrong thing to use. I should say successes and failures because I didn't actually calculate P or Q. But successes was 45. So we have 45 successes and there's 50 altogether. So that means I have 5 failures. So 45 successes, 5 failures. That's what I meant over here. So instead of P and Q, I should probably say success and failure. Wow, my spelling is off this morning. Success and failure are both 5 or more. Okay, calculate the sample proportion. So P hat is X over N, which was 45 over 50, and that gives us 90% or 0.9. Is this consistent with the alternative hypothesis? Yes, 0.9 is greater than 0.7, which is what our alternative hypothesis says, was that it was greater than 0.7. Okay, so now we want to calculate our our variables for solving this problem. And this part, you are welcome to work through in detail, but we do kind of put this all together when we are calculating Z, which shows up in part C. So this is just kind of piecemealing the problem. And I don't really like calling them mean and standard error. What I like to call them better is P, and this is right here. That is the denominator for Z. So we already know what P is. We already know P is 0.7. And then this denominator, well, what we're really looking for at this moment is to look for P and Q. So we have P, which means that Q is 1 minus 0.7, which is 0.3. So this little square root thing that they're showing us is 0.7 times 0.3 divided by N, which is 50. And we're going to put that in our denominator when we go find Z. Okay, so here I'm just going to jump to Z and then I'll come back to that right there. So here we have our Z. Z equals P hat, which we calculated as 0.9 minus P over, and then 0.9 times 0.3 all over our N, which is 50. And we plug that in and we get 3.077. Okay, is this unusual? Yes, because anything greater than 2 is unusual. All right, so let's go back up here to our picture. So we want to sketch the picture. This was a right tail test. Oh, I know what I forgot. I forgot to look at the table. Okay, here we go. We are going to look at the table that is yellow. And what I want you to do, I'm going to turn on this video real quick and see if I can show you what I'm looking at. Right here, so this is the yellow table that we always use. And right here in the bottom corner, it says hypothesis testing critical values. And so we are using right tail, which is the middle column. And then we said that alpha was 0.05. And so that tells us that our critical value is going to be 1.645. So it's that number right in the middle, I'm doing this. This is weird. I'm doing this backwards. Okay, there we go. 1.645, that gives us the alpha and the right tail. Okay, so that's what I need right here. That is where my line is, 1.645, because that line is always going to be the critical value. And then the z that we calculate here at 3.077. And we said it was unusual because it's so small. Z of plus or minus 2 is what we consider normal. And so we have this Z that is way out there. So let's kind of look at some pictures real quick. And just like before with means, we're not using p-values, we're just using critical values. And so the pictures are the same. Left tail test, we have right here. This is our reject region. Right tail test, to the right is our reject region. And two tail test, we have two reject regions. We reject on the left side and on the right side. So we want to draw the picture. We want to shade in what's going on in the reject to tell us which one the reject is, meaning shade to the left for a left tail test, shade to the right for a right tail test, and shade both for a two tailed test. We did that here, and here is our reject region. So we are going to reject the null. That's a 0. Reject the null because our test statistic landed in the region as determined by our critical value. Okay, so we already did this. See the picture above. We already did that for our critical value. And so we can now come to our conclusion. And so this kind of breaks it down in a few parts, but ultimately we are going to reject. This is not the conclusion, but this, we'll write the full conclusion down here. Oh, I guess this isn't really asking for an answer right here. Oh, well, I just answered it anyways. Okay. I answered the one below it. I am going to move that. Ooh, am I that awesome? No. Oh, yes, I did it. Cool. Okay. We are going to reject the null hypothesis, which means we can support the alternative. We determined we can support the alternative. So the conclusion is there is sufficient evidence to support the claim that, and what was our alternative? It seems a little awkward English-wise to say we're supporting the claim that the estimate was too low. I don't know if this sounds weird. So we could just rewrite the alternative. We could claim that the proportion of teenagers who prefer bottled water is greater than 0.7. That the proportion of teenagers who prefer bottled water is greater than, what is it, 0.7 or 70% for my conclusion. You could put 0.7. Or you could say, yeah, that sounds good. So again, we're writing a conclusion. There either is or is not, in this case there is, sufficient evidence to support the claim. The claim is the alternative hypothesis in words. Alternative hypothesis in words. So you don't want to just say the proportion is greater than 70. We want to have all of the words from the problem. The proportion of what? Well, in this problem, we were talking about teenagers prefer bottled water. So that's what we're talking about in our conclusion as well. All right, so now that we have worked through a full problem, I want you to pause the video, go back and look through the second example, the one on the political polling again, and see if maybe you can fill in some blanks that you weren't able to earlier, or if you haven't really read through it or you forgot already what it was about, then take some time and look through that video now. Okay, and we are back. And here we have the political polling. And of course, the first thing we're going to do, well, what I would, if I wasn't in this section, actually, the very first thing I would do is determine if this was a proportion or a means problem. But it doesn't take us very long. According to Civic, 68%, okay, 60%. I'm feeling like this is a proportion problem. And as you read through the problem, it gives you the number of people that were a success, in this case, meaning supporting Barack Obama. And so this is definitely a proportion problem. And while we're labeling things, we have our alpha right there as well. As you've seen, there are examples where alpha is different than 0.05, but very frequently it is 0.05. Okay, so here we want to determine the null and alternative. We said this is a proportion problem. We have our claim of 68%. So the null equals that 68%. And then we need to know what's going on with with our question. So it says determine whether the percent of youth who support Obama has changed. Has changed does not mean greater than, does not mean less than. So it has to mean it is not equal to. Changed is just like different. It's either bigger or less, but it's not equal to. So we have a not equal to problem, which means we have two tails. Now, explain your selection. You don't see this question when I go through the lecture, but I like to keep it in for this lab part because it just makes sure that you know that you did. So the reason we did was whether, I'm just going to kind of abbreviate that, whether the percent has changed. So that tells us both parts of the alternative hypothesis. It tells us percent means it's a proportion, and whether it has changed is telling us the not equal to part of the alternative hypothesis. And like we said before, this is a two-tailed test. Okay, are the conditions met? Well, let's see, we have 35 are considered a success. And then the rest of them, so 60 minus 35, so 25, are considered a failure, and both are 5 or more. So we're good. They're 35 and 25, so yes, we've met the conditions. Okay, so now we're going to calculate the sample proportion. And so we said n was 60 and x was 35. P hat is x over n. Oops, I almost wrote it upside down. 35 over 60. If you ever go to calculate this and your number is bigger than 1, then you know that you did it upside down, because these numbers are just like probabilities because they're p-words, so they have to be between 0 and 1. And so there is my p hat. Is it consistent with our alternative? 583 is definitely different or not equal to 0.68. So yes, because our alternative hypothesis said whatever proportion we get would be not equal to 0.68. Okay, so remember, for mean and standard error, we're just looking for P, and we're looking for that denominator for our test statistic. And so P, we've already calculated, or not calculated, but we already wrote down at the top, but many students lose their P and their mu along the way. And so remember, we wrote that down right here during our alternative hypothesis. We said what P equals. So P equals 0.68, and then denominator, we're just going to have PQ over N all under the square root. And so we have our P already. We need to figure out what Q is. Minus 0.68 equals 0.32. And then our N was 60. People were old. Okay, so we are going to kind of do the picture and calculate our test statistic and all that good stuff. And so this is a two-tailed test. We are still using that yellow paper. And so we have our alpha is 0.05, and this is two-tailed. We should be seeing on your paper one plus or minus 1.96. Remember, this is just a number line with 0 in the middle. So the positive is on the right and the negative is on the left. And so now we want to calculate the test statistic. So we're going to put everything together for Z. Is there a good place to write this? Not really. Z equals P hat 0.583 minus P over this denominator that we just came up with. So that formula is just right there above. That's going in the denominator. And so Z, our test statistic, is going to equal, when we simplify this, negative 1.61. And you just need enough decimal places to know how to compare this. So negative 1.61, I know that is between 0 and negative 1.96. If I had gotten Z equals 1.96, I would want to make sure I had another decimal so I knew if it was greater than or if I was rounding and it was actually less than. But this one I can tell is in that white space in between. Is our test statistic unusual, no, it is between -2 and 2. This is more like flashback. You know how I say we're always studying for the final. So this isn't really necessary to be thinking about here, other than, oh, it's not really unusual, so it's more likely to be in the fail to reject section. However, I'm not going to be asking you that on the test. It's just good to think about what is usual and what is unusual, because those topics will come up when we get to the final. Okay, so we have got enough information to see that our picture or our value lies right here in the fail to reject part of this picture. All right, so what we conclude about null, we're going to fail to reject the null. Something spooked the horses outside, and when the horses get spooked, then the dogs go crazy. That is what you are hearing, and I can't see outside from where I'm sitting, but my guess would be there's turkeys running around the horses. So that's just like that. Okay, so if we fail to reject the null, then we cannot support the alternative. And so interpret your solution. That's weird. Did you perform all the steps? Okay, we're not going to worry about that. That's kind of in our way at the moment. Interpret your decision in the context of the problem. There is not sufficient evidence to support the claim. Remember, the claim is the alternative hypothesis that the percentage of youth who support Obama is different from or different than 68%. So the claim, again, this is always our alternative in words. Our alternative was that percentage, that P, our proportion, is different, is not equal to 0.68. Another way you could say that is the percent of youth who support Obama. We cannot conclude that the percent of youth who support Obama has changed since 2008. But sometimes just literally copying the words from the problem kind of sounds a little weird and makes you think too hard. So then you can just kind of rewrite this part in symbols in words. So not equal to is always different. Than. All right, so there is one more problem here, school bullying. If you would like more practice, go ahead and work through that problem and you can email it to me and we can talk about if there's any parts that you're having trouble on. Also, if you want to kind of put a bookmark here, because I know the next test is a long ways from now, you could just kind of bookmark this and say, hey, here's a good hypothesis test practice that I could do later when I need a refresher. So either one of those are good plans. Okay, that is it for hypothesis testing for proportions for the 95S lab.